Suppose the demand function for a firm's product is given by QDX equals 3 minus half PX minus 2.5 PY plus M plus 2A, where PX is the commodity price, PY is the price of a related commodity, M is per capita disposable income, A is advertising expenditure. PX equals 10, PY equals 4, M equals 20,000, and A equals 250. So before we start solving the questions, colleagues, from this demand equation, okay, what is quantity demanded of this good dependent on? When you look at the equation, which ones are the independent and the dependent variable? Anybody to give it a try? How can you interpret this equation? Which one is the dependent, independent variable? And then how are each of these variables relating with quantity demanded from the signs of in the equation here? So quantity demanded is dependent on the price of this good. So as we see, it's a negative here. It means there's an inverse relationship between the price of the good and the quantity demanded. If price goes up, quantity demanded goes down. Quantity demanded is also dependent on the price of the other good Y. We see here there's a negative sign, so it means there's a negative relationship between quantity demanded of good X and the price of good Y, meaning if the price of good Y goes up, the quantity demanded of good X goes down. Quantity demanded is also dependent on income. And we see there's a positive sign here, meaning if income increases, quantity demanded increases. And then finally, quantity demanded is dependent on advertising. Okay, since it's a positive sign here, meaning if advertising increases, quantity demanded also increases. Okay, so these variables on the right, these are the independent variables. And quantity demanded is the dependent variable. Are we okay with this, colleagues? So that in the exam, when you see an equation like this, you're already interpreting it before even go to answer the question. Any questions before or any clarifications? Okay, part one, it says determine the on price elasticity of demand and state whether demand is elastic, inelastic, or unitary elastic. Okay, so here we don't have our P1s and our Q1s. Okay, so we have to use the equation of this equation here, right? So the on price elasticity of demand, which is E px, is the partial derivative of our demand function q dx over the partial derivative of the price of good x multiplied by the price of good x over the quantity demanded of x. That's how you get the own price elasticity of demand. So, first things first, we need to partially differentiate this fraction here. Okay, so let me put it here on the board. Oh, it's on the board already. So whenever we say we're getting the partial derivative, okay, it means we are going to only focus on one variable in the equation. In this case, we're getting the partial derivative of the demand function with respect to the price of good X. So you look at what's in the denominator. That is the variable that you are considering. If no, if any element in the equation doesn't have that variable, the px in this case here, then it disappears. This 3 doesn't have a px, it goes. This negative 2.5 doesn't have a px, it goes. M doesn't have a px, it goes. 2a doesn't have a px, it goes. The only one that has a px is this negative half px. Okay, so this px is like it's to the power 1. And remember, with differentiation, you multiply the exponent with the coefficient 1 times negative half. You're going to get negative half. Then you subtract a 1 from the exponent. 1 minus 1, that is 0. So you have px to the power 0. And colleagues, what do we say? Anything to the power 0, what does it become? It equals yes. So this is our partial derivative here. Now we've just done the first part of the equation here. Okay, because we have to multiply it by the price of px over quantity demanded of good x. Okay, so that we can get our final value and see the determine the elasticity of demand. So these values that you've been given here, as you can see, in these type of questions, they'll give you this in px equals 10, py equals 4, m equals 2000, a equals 250. These values here, the reason why they're giving them to you is so that you substitute in this demand equation. Okay, so if we substitute in our equation, it becomes equals 3 minus half px, we substitute it with 10, minus 2.5, py substitute it with 4, plus m, which is 2000, 20,000 I mean, plus 2, substitute it with 250, so 2, 250. Let's get our calculators. So half minus 10, that is negative 5. So this becomes 3 minus 5. Negative 2.5 times 10 times 4, that is 10, minus 10, plus 20,000 plus 2 times 250, that is 500, plus 500. So in our calculators, let's put it in. 3 minus 5, that's negative 2. Negative 2 minus 10, that is negative 12. So negative 12 plus 20,000 plus 500, what do we get? Negative 12 plus 20,000 plus 500. 20,488. So this 20,488 represents this quantity demanded of good X. All right. So in our equation here, for the on price elasticity of demand, Partial derivative of q dx over partial derivative of px was negative half, multiplied by the price of good x, 10, divided by the quantity demanded, 20,488. Okay, so negative 1 times 10, that is negative 10. 2 times 20,488, 40,976. Negative 10 divided by 40,976. Hold on. So this is going to be negative, not, yeah, negative 0.300024. Okay. Now we said for price elasticity of demand, okay, you always get the absolute value because, as we said, when price increases, quantity demanded has to reduce. So you're always going to be getting negatives. Okay. So we get the absolute value. It just means we ignore the negative side. So we get 0.1230024. And this value, we compare it with 1. So since it's less than 1, is demand elastic, inelastic, or unit elastic? Our value is less than 1. So what can we say about the demand? Is it price elastic, inelastic? Wonderful. Demand is inelastic.